Okay, so you've sent us this mountain of information about Google's Willow Chip articles, research papers, even some excerpts from Jörg-Owe essay. You're clearly looking to go pretty deep on this, and you've definitely come to the right place.
Yeah, it seems like you want to go beyond just the basics. You want to really understand what this Willow chip could mean for the future of computing AI, maybe even for society as a whole.
Exactly. So think of this as like your deep dive crash course on all things Willow. What makes it special? What are the potential applications? And some of the nuances and challenges that Schneepat brings up in his essay.
Speaking of Schneepat, he makes a really interesting point right off the bat. He argues that Willow isn't just like another step forward. It's like a potential paradigm shift in how we approach computing,
Right.
especially when it comes to AI.
Okay, I'm intrigued. But before we get too far ahead of ourselves, let's just start with the basics. What
Right.
exactly is the Willow chip? It's not your typical CPU, right?
No, it's not. Willow is a quantum computing chip. But what makes it unique is that it's specifically designed for AI and machine learning.
Quantum computing. Okay, so we're not just talking about faster calculations. We're talking about a fundamentally different way of processing information.
Yeah.
That's got to tie into Schneepat's whole paradigm shift idea, right?
Absolutely. You see, traditional computers use bits, which can be either a 0 or a 1. But Willow, being a quantum computer, uses qubits. And these qubits can, thanks to the wonders of quantum mechanics like superposition, exist in multiple states at the same time.
All right, now that's where things start to get a little mind-bending for me. So how did that translate to actual processing power? What makes this such a game changer, according to Schneepat?
Well, think of it like this. With a traditional computer, you're essentially tackling problems in a linear way, exploring one solution at a time. But a quantum computer, thanks to superposition, it can explore multiple solutions simultaneously. It's like running millions of simulations all at once.
So it's not just speed. It's a completely different approach to solving problems. I see why Schneepat is excited about this. But how does Willow's specific design for AI come into play here?
That's a great question. So many AI algorithms these days rely on probability and massive data sets. Quantum computing, with its ability to analyze vast amounts of data simultaneously, is kind of a perfect fit for this.
So it's like Willow's architecture is optimized for those calculations that are at the heart of AI, and Schneepat suggesting that this could lead to breakthroughs in areas where traditional computing just hits a wall.
Precisely. He points to Willow's performance in benchmarks like random circuit sampling or RCS. This is basically a test to assess how well a quantum computer can handle complex computations, and Willow is exceeding expectations.
Okay, I'm going to need you to break down RCS for me. What exactly is it measuring? And what makes Willow's performance so remarkable?
Sure, so RCS basically measures how well a quantum computer can manipulate and sample from a massive set of probabilities. And this is directly relevant to AI because so many algorithms rely on probability distributions for tasks like image recognition or natural language processing.
So a high score on RCS means that Willow can handle the kind of probabilistic calculations that are essential for a lot of AI applications way more efficiently than a traditional computer.
Exactly. And this goes back to Schneepat's whole argument about a paradigm shift. He thinks Willow's performance in RCS is a glimpse into a future where AI development isn't limited by computing power in the same way it is today.
That's a bold statement. Is there any evidence to suggest that this actually translates to real-world AI applications?
Well, it's early days, but Schneepat does highlight some promising research. For example, there are studies showing that certain quantum algorithms can outperform classical algorithms in tasks like image classification and drug discovery.
So while it might not be mainstream yet, there are tangible signs that quantum computing, and that Willow specifically, could significantly change how we develop and utilize AI.
Exactly. Schneepat wants us to see Willow not just as a faster chip, but as a potential catalyst for a whole new era of AI innovation.
Okay, I'm starting to see the bigger picture here. But Schneepat also talks about the challenges facing quantum computing. He's not ignoring the hurdles, even as he's optimistic about the potential.
Oh, absolutely. And one of the biggest hurdles he discusses is error correction. Quantum computers are extremely sensitive to environmental interference. Due to the delicate nature of those quantum states, even the slightest disturbance can introduce errors.
So it's like building a house of cards in a windstorm. How do you even begin to address that level of sensitivity?
Well, it's one of the most active areas of research in quantum computing. Schneppat dives into some of the approaches being explored, and they often involve complex redundancy and error checking protocols.
So it's not just about building the quantum computer itself, it's about creating an environment where it can function reliably.
Exactly. And Schneppat argues that this need for such a controlled environment could impact the scalability of quantum computing.
Scalability. Okay, what do we mean by that? Is it just about building bigger chips with more qubits?
That's part of it, but it's also about how feasible it is to maintain those very precise environmental controls. As quantum systems get larger and more complex, I imagine trying to maintain the perfect temperature shielding and isolation for a system with millions or billions of qubits.
That sounds like an engineering nightmare. So while the potential of Willow and quantum computing is huge, it sounds like there are some serious practical challenges to overcome before we see it widely deployed.
Absolutely. And Schneppat is very clear-eyed about that. He's not saying Willow is a silver bullet. He's saying it represents a crucial step forward and a glimpse into a future where quantum computing could reshape our technological landscape. And speaking of reshaping the landscape, Schneppat really gets into the eventual societal implications of this whole quantum computing thing. He doesn't just focus on the tech, he wants to explore the human side of all this.
Okay, now you've got me hooked. What kind of societal shifts is he talking about? And why is Willow such a focal point for him?
Well, one of the first things he looks at is the economic impact. He argues that the development of quantum computing is already causing like a global race, with countries trying to get ahead in this whole new field.
It sounds like the space race 2.0. But how does this play out in the real world? Is it just about national pride, or are there actual economic benefits at stake?
Schneppat thinks it goes way beyond national pride. He says that the countries who lead in quantum computing could have a serious economic advantage. Think about it. Industries like finance materials, science, even pharmaceuticals, they all rely on heavy-duty computation. Quantum computing could totally revolutionize these industries, leading to new discoveries, more efficient processes, a real competitive edge.
So it's not just about who builds the fastest quantum computer, it's about who can use that power effectively to boost their economy. Schneppat seems to be saying that Willow, being one of the most advanced quantum chips out there, puts Google and maybe the US in a pretty strong position.
Exactly, and it doesn't stop there. Schneppat also explores how this could impact the job market.
Okay, now that's where things start to get a little unnerving. Automation is already a big concern with regular computers. I can only imagine what quantum computing could do.
It's a complicated issue, and Schneppat doesn't shy away from it. He acknowledges that, yeah, some jobs might be displaced as quantum computing takes over tasks that humans currently do. But he also points out that this tech could create entirely new industries and jobs that we can't even imagine yet.
So it's not just a simple case of robots are taking our jobs. It's more like a reshuffling of the entire job landscape with both wins and losses that are really hard to predict. What does Schneppat suggest we do about this uncertainty?
He stresses the need for policies and education systems that can adapt to this rapidly changing world. He says governments and educational institutions need to invest in training programs that give workers the skills they'll need for this new quantum era.
So it's not about resisting the change, but about getting ready for it and making sure that the benefits are spread out fairly.
That's Schneppat's main point. He thinks that with some foresight and planning, we can use the power of quantum computing for the good of everyone.
That makes sense. But he's not ignoring the potential downsides either. What are some of the concerns he raises about the broader impact of this tech?
Well, one area he really digs into is the potential for misuse or for it to fall into the wrong hands. He talks specifically about cybersecurity.
But now that's a scary thought. I imagine a powerful enough quantum computer could crack encryption codes that are supposed to be unbreakable.
That's exactly what Schneppat's worried about. He points out the risk of quantum computers being used in cyber warfare or for hackers to get access to sensitive data.
So the same tech that could revolutionize medicine or help us find clean energy solutions could also be used to disrupt global security or steal people's financial information. It's a real double-edged sword.
Exactly. And Schneppat doesn't pretend to have easy answers. He admits there's no quick fix, but he stresses how important it is to stay ahead of the game.
What does staying ahead of the game look like in this case?
He suggests a multi-pronged approach. He's a big advocate for investing in quantum-resistant cryptography, basically developing new encryption methods that can hold up against quantum computers. He also emphasizes international cooperation and ethical guidelines for how we develop and use this technology.
So it's not just about building better firewalls. It's about setting global standards and making sure this powerful technology is used responsibly. Schneppad seems to be saying we need a global conversation about this, not just a tech race.
That's a great way to put it. He believes that the future of quantum computing isn't something that should be decided by a few tech companies or governments. It's a conversation that needs to involve everyone, ethicists, policymakers, even the general public.
Okay, I'm seeing a pattern here. Schneppad seems to approach every aspect of quantum computing with this focus on human agency and the need to be proactive and thoughtful about how we engage with it. He's not just a cheerleader for the tech. He's someone who wants us to really wrestle with its complexities and make sure it's used for good.
You've got it. And this leads him to a really interesting point about the potential of quantum computing to be a great equalizer.
A great equalizer. How so? Wouldn't access to this kind of technology be limited to those who have the resources to develop and use it?
That's a valid concern, and Schnepphat recognizes that. But he argues that quantum computing could actually make advanced technology more accessible than ever before.
Okay, I'm listening. Saying, how could something that requires so much investment and expertise become more accessible to everyone?
Schnepphat points to the potential for cloud-based quantum computing platforms. Imagine a future where anyone, even small organizations, could access quantum computing power through the cloud, just like they access data storage or software today.
So instead of having to build their own quantum computers, they could basically rent processing time from companies like Google who already have the infrastructure. That would definitely make it easier for more people to get involved.
Exactly. And Schnepphat believes this kind of accessibility could empower individuals and communities who haven't always had access to the latest technology. He sees the potential for quantum computing to fuel innovation and problem solving on a global scale, not just in research labs or big corporations.
That's a pretty optimistic outlook, but it's also really compelling. If quantum computing can be made accessible like that, it could be a force for positive change worldwide.
That's Schnepphat's main argument. He wants us to see the potential for quantum computing to be not just a disruptive technology, but a truly transformative one that can empower individuals, address global challenges, and ultimately create a better future for all of us.
I'm starting to see why you're so enthusiastic about Schnepphat's work. He's not just talking about bits and qubits. He's talking about the human impact of this technology and how we can steer it in the right direction.
You got it. And that brings us to one of his most thought-provoking points. He argues that quantum computing isn't just a technological revolution, it's a philosophical one.
All right, now you've really piqued my curiosity. What does he mean by a philosophical revolution?
Schnepphat believes that quantum computing forces us to ask some fundamental questions about what it means to be human in an age of increasingly powerful machines. He asks things like, what are the limits of human ingenuity? What does it mean to understand and control a technology that works in ways that are so different from our traditional view of the world?
Those are some heavy questions.
Yeah.
So it's not just about learning how to program these quantum computers. It's about rethinking our place in the universe and how we relate to technology.
Exactly. Schnepphat argues that we need to approach quantum computing with a sense of humility and a real awareness of its profound implications. It's not just a tool, it's a force that could completely change how we understand ourselves and the world around us.
Wow, that's a powerful statement. It sounds like Schnepphat is urging us to think about quantum computing, not just as scientists or engineers, but as philosophers and human beings wrestling with the deepest questions of existence.
That's a great way to put it. He believes this technology demands our full attention, not just our technical skills. We need to think about the ethical, societal, even spiritual implications.
I'm starting to see why you find Schnepphat's essay so fascinating. He's going beyond the typical hype and fear around new technology. He's challenging us to engage with quantum computing on a much deeper level.
Absolutely. And that leads him to advocate for a broad societal conversation about all this. He argues that this shouldn't be left to a small group of experts. It's a conversation that needs to involve everyone, from scientists and engineers to artists, philosophers, and everyday people.
So it's about democratizing not just access to the technology itself, but also the discussion about its implications and its role in our future. I think I'm starting to understand Schnepphat's message.
And that brings us back to Willow Schnepphat sees this chip as a symbol of this crucial moment in human history. It represents not just a technological leap, but a societal one. A point where we need to decide together how we want to navigate this uncharted territory of the quantum era.
Okay, I'm officially on board with Schnepphat. He's managed to take a discussion about a computer chip and turn it into a reflection on the human condition and our relationship with technology. I'm really interested to hear more about his thoughts on how Willow could impact specific areas like healthcare and energy.
Those are definitely two areas where Schnepphat sees huge potential for positive change. Let's start with healthcare. He imagines a future where quantum computing could completely revolutionize drug discovery, personalize medical treatments, and even diagnose diseases much earlier and more accurately.
So it's not just about treating diseases better. It's about understanding them on a deeper level and maybe even preventing them altogether.
That's the key takeaway. Schneppat highlights the potential for quantum computing to analyze massive amounts of data on genetics, protein structures, and clinical information to find patterns and insights that we just can't see right now.
It sounds like we're talking about a whole new level of personalized medicine, where treatments are tailored not just to a specific disease, but to each person's unique genetic makeup and medical history.
That's exactly the vision Schneppat lays out, and it's starting to gain traction in the medical world. He points to some early research that suggests quantum algorithms could speed up the development of new drugs and therapies, potentially leading to breakthroughs in treating diseases like cancer and Alzheimer's.
That's incredibly exciting. And it ties back to Schneppat's point about quantum computing being a potential solution to problems that seem impossible to solve. But what about the energy sector? How could Willow and quantum computing contribute to a more sustainable future?
That's another area where Schneppat sees a lot of promise. He highlights how quantum computers could be used to optimize energy grids, making them more efficient and resilient.
So we're talking about reducing energy waste and making our power systems more reliable. That's definitely a step towards a more sustainable energy future. But Schneppat doesn't stop there, does he?
Nope. He also talks about using quantum computing to develop new materials for things like solar panels and batteries, making renewable energy sources more efficient and affordable.
So it's not just about using energy smarter. It's about improving the technologies we use to generate clean energy in the first place. That's a big part of addressing climate change.
Exactly. And Schneppat even goes a step further. He suggests that quantum computing could help us design entirely new ways to store energy, which is essential for making renewable energy a truly reliable and scalable alternative to fossil fuels.
I'm starting to see the scope of Schneppat's vision. He's not just talking about making small improvements. He's talking about fundamental changes in how we approach healthcare energy and our relationship with the planet.
You're getting it. And that brings us back to the idea of quantum computing as a potential catalyst for a more sustainable, equitable, and just future. Schneppat believes that this technology, if used responsibly, can help us tackle some of the biggest challenges humanity is facing.
It's an inspiring vision, but it also feels urgent. Given the scale of the challenges we face, like climate change and global health crises, it seems like we need these breakthroughs sooner rather than later.
You're right. And Schneppat doesn't sugarcoat things. He acknowledges that there are some serious challenges ahead, both technical and societal. We still need to figure out scalability and error correction, and we need to have open and honest conversations about the ethics of this technology.
So it's not just about building bigger and better quantum computers. It's about making sure we use them wisely and for the benefit of everyone.
That's the heart of Schneppat's message. He wants us to approach quantum computing with a sense of responsibility, recognizing both its incredible potential and the potential risks.
I think we've covered a lot of ground today. We've delved into the technical side of Willow, explored its potential applications, and grappled with the bigger questions it raises. I feel like I have a much better understanding of this technology now, and I'm definitely excited to see where it goes from here.
Me too. And I think Schneppat would be happy that we're having this conversation. His whole goal was to get people thinking about these things, and I think we've done that.
Before we wrap up, is there anything else from Schneppat's essay that you want to highlight? Any final thoughts you want to leave our listener with?
Yes, actually, there's one point he makes that I think is worth emphasizing. He argues that quantum computing has the potential to be a great equalizer to democratize access to advanced technology and empower people and communities all over the world.
That's an interesting perspective. How so?
Well, right now, access to powerful computing resources is mostly limited to big companies and governments. Quantum computing could change that. It could make it possible for smaller organizations and even individuals to have access to the same level of computing power.
So it could level the playing field, giving more people the tools to innovate and solve problems.
Exactly. And that's a vision of the future that I think is really exciting. A future where technology is used to empower people, not to divide them.
It's pretty amazing how Schneppat brings all these things together. You know, the technological advances, the economic shifts, the ethical stuff, even some philosophy.
Yeah.
It's a lot to take in. But I think it's really important for understanding what Willow really represents.
Yeah, he's definitely pushing us to look beyond just the cool tech stuff and really think about the bigger picture. It's not just about faster computers. It's about how this technology could change our world, our societies, even how we see ourselves.
And he's not shying away from the potential problems either. He clearly knows the risks are there, but he doesn't let that overshadow the potential for good.
Right, that's a big part of his approach. He acknowledges that it could be misused, that access might not be equal, that there could be unintended consequences. But he doesn't think that means we should stop progress. He sees these as challenges that we need to actively address.
It's like he's saying, here's this incredible tool, but it's up to us to use it responsibly and for everyone's benefit. It's a big responsibility, but also a really exciting opportunity.
He really emphasizes the role that we humans have in shaping where quantum computing goes. It's not something that just happens to us.
Yeah.
It's a technology that we're creating and guiding.
And that connects back to his point about needing a broad conversation about all this. It can't just be a few experts making decisions about how this technology is developed and used. We all need to be involved, informed, and part of shaping its future.
Yeah, he's calling for a collective effort, a shared responsibility to steer quantum computing in a direction that benefits all of humanity. It's a vision that needs collaboration across different fields, across borders, across different perspectives.
Okay, I'm curious. Shifting gears a bit, we've talked a lot about Schneppat's ideas, but what about you? As someone who's really involved in this field, what excites you the most about the future of quantum computing?
For me, it's the potential for breakthroughs in areas that have felt impossible for so long. Think about the possibility of personalized cancer treatments tailored to someone's genes, or creating entirely new sources of energy that could power our planet sustainably.
It's not just about solving the problems we have now, it's about rethinking how we approach them altogether. Quantum computing gives us a whole new set of tools, and the possibilities are mind-blowing.
It's a shift from making small steps to potentially giant leaps forward. It's about finding solutions we can't even imagine yet. That's what really drives my passion for this.
But I imagine there are also things that worry you about all this. Concerns about the downsides, the ethical dilemmas, the things we can't predict.
Of course, the power of this technology is real, and with that power comes responsibility. I worry about it being used for the wrong reasons, about making existing inequalities worse, about unintended consequences that could really disrupt society.
It's a good reminder that every new technology comes with both good and bad. It's up to us to figure out how to use it for good while minimizing the risks.
Exactly. And that's why I think Schneppat's call for a big conversation about all this is so important. We need to talk about these questions openly and honestly, not just among scientists, but as a global community.
Okay, so to wrap up this deep dive, I want to go back to something Schneppat mentions in his essay. He talks about Willow's potential impact on different areas like healthcare and energy. But given that it can analyze complex systems and model different outcomes, could it also be a key tool in addressing climate change?
That's a great point, and I think it gets at the heart of what Schneppat is trying to say. Quantum computing isn't just about solving the problems we already know about. It's about giving us the tools to understand and predict complex things in ways we never could before.
So we could use it to model climate change scenarios with incredible accuracy, to develop better strategies, to mitigate its effects, maybe even to design entirely new technologies to capture and store carbon.
Exactly. That's the kind of transformative potential. Schneppat is talking about quantum computing could be a game changer in our fight against climate change, but it'll take collaboration, innovation, and a willingness to think in new ways.
It reminds us that the future isn't something that just happens to us. It's something we create through our choices, our actions, and our collective efforts. And with tools like the Willow Chip, we have the potential to build a future that's not just technologically advanced, but also sustainable, just, and equitable.
Well said. I think that's a great way to end this conversation. Thanks for joining us on this journey into the world of quantum computing, the Willow Chip, and the fascinating ideas of Jörg-Owe Schneppat. It's been a great exploration, and I hope you'll continue to think about these issues.
And to our listeners, if you're interested in learning more about Schneppat's work or the latest developments in quantum computing, we'll be sure to include some resources in the show notes.
Until next time, stay curious, stay engaged, and keep exploring.
And remember, the future is not set in stone. It's a blank canvas waiting for us to paint our vision on it.